Welcome to part 7 of Photon Networking with Unity. This video I will be talking about spawning objects, specifically a player, and moving them around the scene. Beforehand, we are just going to fix up a couple things real quick. The first thing we need to do is make it so only the master can start the match. So go to your scripts folder, and then your current room folder, and then open up current room canvas, as this is the script we use to start the match. To do that, we'll just have to modify each one of these start methods. And we're just going to check if we're the master, or rather if not the master. So if not Photon network is master client, return. And I'm just going to copy this and paste it right up here as well. So now if we click the start button when you're not the master client, it will not attempt to load the level. You can go ahead and close out of your current room canvas. Now jump on over to your player network script. We need to make it so when the master joins the game scene, it also calls the RPC loaded game scene, and we're going to do that by replacing the players in game equals 1 with this line right here. The reasoning for this is if another client never joins, loaded game scene will never be called. And that is the solution to fixing that problem. Okay, let's work on making our player prefab. So go back to the editor. Open up your game scene. And I already have a cube here. I'm going to use that for my prefab, but I think I'll add on a sphere to know which way the front is. So right click your cube, go to 3D object, and then add a sphere. And Z is your depth, so go ahead and pull that out to the front. And if you're wondering where I'm getting my depth and Z axis from, you'll see this blue handle pulls it forward and back. And if you look up top here, it tells me that blue is the Z-axis, so that's how I know. Reselect your cube in the hierarchy if it's not currently selected. Rename it to New Player. And under Components, add a Photon view. This will let us issue Photon commands onto it, as well track it if we need to. Now under the Observed Components, select Transform and drag that onto it. Keep the serialization at position and rotation, as well unreliable on change. The transform serialization is kind of obvious. These are values which are passed on through the update, so you can only update the position, the rotation, the scale, or the position and rotation, or all of them at once. The observe options off means that this information will not be relayed to any of the other clients, so the transform information about this particular object will not be sent to anyone. Reliable delta compressed means that it will be sent, but it will be sent in order and only whenever a value has changed. So if the player has moved, for example. Unreliable will constantly send the values, and they may arrive in any order. Generally they will arrive in the same order they are sent, but not necessarily. Unreliable will also allow packet dropping. Unreliable on change is the same as unreliable, except that it will only send data when the transform has changed location or rotation. Now we're going to make a very basic movement script for this object. So jump into your scripts folder, right click, create new script. We will call it player movement. Go ahead and open it up. Now since we are going to be relaying information from the script automatically, we need to add in front of mono behavior photon dot. So it should say photon dot mono behavior. This is often overlooked, so make sure you take care of that. Erase the start method, and under update, let's do check input, and then we're going to make that method now. So private void check input, and what this is going to do is it's going to handle the player movement. I'm going to set a flat move speed of 1 float. If I can type here. And I'm going to type a flat rotation speed of 5 float. Then I'm going to grab the current vertical axis. So I'm going to do vertical equals input dot get axis vertical. I don't know if the V has to be capitalized, but in every example I've ever seen it was. So I would just say go with it. Same thing, except I'm going to do one for horizontal now. I'm not going to go into the details of how, but you can configure what keys trigger vertical up and down, as well which trigger horizontal left and right. So if horizontal replies back with 1, it's considered right. If it replies back with -1, it's considered left, just as vertical up is 1 and backwards is -1. So now we need to update our transform position with the values we pull. So transform.position plus equals, so we're going to add on to its current position, transform.forward times vertical times move speed times time dot delta time. And I'm actually going to increase my move speed by a bit, actually, because I'm multiplying it by delta time. So I'd say increase it to 100 and increase the rotation speed to 500. It's probably going to be a little over the top. We'll find out in a second. So then for rotation, transform.rotate, which will add rotation, new vector 3, and we're going to add the horizontal rotation on the y-axis, which will turn it left or right. So I'm going to do horizontal times rotate speed times time.delta, and then 0 for the z-axis. So what we have here is it'll take however much we're holding up or down, so it'll be anywhere from -1 to 1, and apply that to our position in a forward manner, just as it will do the same with the horizontal movement left and right to rotate left or right on the y-axis. Okay, go back to the engine, select your new player object in the hierarchy, drag on the player movement script. Now let's go ahead and test it and hit play. Okay, so the rotation seems to be working just fine if you press, use your arrow keys left or right, or A and D, and the same thing with forward and back. It seems to be doing okay. We went out of camera view pretty quick, so I think I'm going to actually go to my camera, and on the blue arrow, I'm going to drag it a bit away just so I have more room to move around. I'm going to hit play just to test it out. Yeah, I think that'll work fine. So I'm going to set my camera to -70. If you need a value to use, set it to -70 on the Z. Save your scene. Now automatically, since the new player object has a photon view and that you're observing its transform, its position and rotation will automatically be updated to all clients. However, at its current state, any player can control any number of objects owned by any other player. So we have to make sure the object is owned by the player trying to control it before we allow it to move. So go back into Visual Studio. You should have your player movement still open. Before we can call check input, we will need to make sure that the photon view component belongs to the player owning this object. So to do that, we have to get a reference to the photon view component. So first, let's make a new photon view variable, and I will call it photon view. I'm going to set the scope to private. And then let's add our awake method. And we're just going to do photon view equals get component photon view. Now that it should be assigned, we can use it in the update function. So we're going to do if photon view dot is mine. Couldn't remember the property for a moment. call check input. So if Photon view is mine, meaning if the person trying to control it does indeed own the game object, call check input. Let's go back to the editor. Now we have to make this into a prefab so that we can spawn it, but it's not going to go in our prefabs folder. Whenever you spawn a prefab using the server, or whenever you want an object to appear on all clients, it actually has to be in the resources folder. So we don't have one currently, so select assets, right click, create folder, call it resources, open it up. I'm going to make a new folder and I will call it prefabs. And then I will drag my new player into prefabs. Go ahead and delete the new player object from your hierarchy. And now I want to spawn it when all players are in the match. And if you recall, we handle registering when all players in the game room under the player network. So I'm going to go into the networks folder under my scripts and open up player network. I'm going to make a new method, and it will be a pun RPC method. I will call it private void RPC create player. And I'm going to spawn the player at the same X and Z, but I want the height to be random. So I'm just going to do float random value equals random.range 0f to 5f. So it's just going to be anywhere between 0 and 5 in height. So now I need to do photon network dot instantiate. Normally you would just call instantiate without the photon network if you were doing something locally, but to have it spawn on all players you have to put photon network dot in front of it. First you must specify the path of the object inside the resources folder. So I'm going to do path dot whoops, looks like I need to specify a namespace, so I'm going to type in path using system.io, there we go, dot combine. I'm going to use prefabs because it's in the prefabs folder, and then I'm going to use new player because that is the name of the prefab. And now I need to set its location, which will be vector3.up times random value. I'm going to use quaternion identity, which is essentially the same thing as saying no rotation or default values. And I'm going to set the group to 0. I'm not going to talk about what a group is. You can look that up if you're interested though. Now I just need to make it so that when all the players are in the game, RPC create player is called on all clients. So that's pretty easy to do. Under all players are in the game scene, just hit return and do photon view.rpc RPC create player photon targets.all. So it will execute this method on all players and everyone will get their own little prefab. Go ahead and save and head back to your editor. Save your scene and then go back to your main scene. Now I'm going to go to File, Build and Run. Launch the standalone executable as well, play in your editor. And you can start a run for either the editor or the executable, it doesn't really matter. So I'm just going to make a room, join it, and you'll notice I can't start it anymore on the client, it has to be done on the master now. Okay, so right away you can see that there are two cubes in the scene, they're just stacked on top of each other. So I'm going to go over to the executable here. I'm going to use left and right to rotate, and it does appear to be updating. And I'm going to move using the forward and back key. And I'll go over to my editor, move him closer to the camera, check the executable, and it does appear to be working. Now you'll notice it is a bit choppy. That is something we need to fix. So let's take a look at that now. Go ahead and close out of the executable and stop the editor. So there are two things that are going on that we have to consider. One, the packets are potentially not being sent to the server and then back to the client quick enough, which is causing skipping. And secondly, the transitioning between player positions is not being smoothed out. So whenever you move from one point to another, you're not going to get every single movement step sent as a packet, because that would just be overwhelming for the server. So we have to actually work on smoothing that out. To begin, we have to make a change to our player prefab. So go into your prefabs folder located inside your resources folder, select new player, and where you're currently observing the transform, instead drag the player movement script component into that location. It's very important you drag the component, not the script itself. So do not go into your scripts folder and drag the script into there. It has to be the attached component. And what this essentially does is, instead of looking for changes on the transform, it will look for changes in the script, which you can manually handle, which will in return let us smooth out the movement. Once you have that dragged onto the observed component, go ahead and open up your player movement script. We need to add a couple variables up top. The first one's going to be a vector3. So private vector3, we'll call it target position. This is the position in which we want the object to ultimately end up if it's not ours. Then we need to do a private quaternion. I'll call it target rotation. Now we need to add another method. I will call it smooth move. So private void smooth move. And in this method, we're going to lerp the position between the current object position and the desired target position. So we're going to do transform.position equals vector3.lerp transform.position for its current position, target position for the goal position, and we're going to lerp it at a value of 0.25, which is about 25% of the way. Now, the higher this value is, between 0 and 1, the more it will be towards the target position. So if you have it at a lower value, it will be more smooth, but there will also be more drag as well, or more delay, I should say, between where the player actually is versus where you're showing he is. Now we need to do one for the rotation as well. So we're going to do transform.rotation equals quaternion dot rotate towards transform.rotation as the start, target rotation as the end, and I'm going to use rotation speed of 500 times time dot delta time. And the reason we use rotate towards instead of just updating the Euler rotation or Euler angles is because if you just update the angles, it will not necessarily take the shortest path. And if you're going from, for example, let's say 10 to negative 290, whereas that might only be, a couple units one way, it might actually rotate around the complete opposite direction, which will spin your object and make it look kind of funny. Rotate towards automatically takes the shortest path. So save your script. And now we need to call smooth move when it's not our transform that we're updating. So up here under update, we have if photon view is mine, check input, and input will handle its position and rotation. And that's fine because that updates every frame, so it'll be smooth. But if it's not ours that's updating, it will only update when we get packets, and that's when we would use smooth move. So very simple. If we own the object, check for input. If we don't own the object, then use smooth move to transition it into where it should be. And you're probably wondering how we determine the target position and rotation. That's where we observing this script comes into play. So there's a method you can access that's part of the Photon package, and that is private void on Photon serialize view. The first parameter is a Photon stream. I'm going to call it stream, and the second parameter is a photon message info, and I'll call it info. And this is called every time you receive a packet for this object, whether it's your object or someone else's object. And one thing to note, this will not be called if you are alone on the server. Why? I don't know. I'm not actually sure. It doesn't really make a lot of sense to me, but that is something I discovered. And secondly, it will only be called if you are observing the player movement script. So in order for this method to fire inside a script, you must be observing the script. So now we need to check if we are the one sending the data or receiving the data. So to check if we are sending the data, we will do if stream dot is writing equals true. So that means if it's writing, we're the ones writing the data. I'm going to do else and then 2 brackets for if we are reading the data. So under the write data, we're going to do stream dot send next transform dot position, and I'm going to do stream dot send next transform dot rotation. So if we're writing the data and it's time for us to send the packet, the first thing we're going to send is the position and then the rotation in that packet. And the order can be whatever you want, but keep in mind what you put because it has to be read in the same order. So let's go ahead and jump back down to the else statement. If we're not writing, we're reading. So we're going to do target position equals vector3 because you have to cast it as it comes in as an object, which the type is not currently known. Stream dot receive next, which will pull the first entry out from the stream. And you need to do target rotation equals quaternion because that's the type we're passing in. Stream dot receive next, which will pull the next value from the stream. So if you tried to do it this way, for example, you would get an error because the first object coming through is a vector3 and not a quaternion. So go ahead and save everything. Now if I were to compile and hit play, I already know this would be a little more smooth, but it's still going to be a bit choppy. I could smooth it out by changing this to like 0.1, but I don't really want that much drag on my players. I want the movement to be more accurate, especially if this is a first-person shooter. So the way you can fix that is to actually bump up how many packets are being sent. Good thing about that is you're going to get more accurate information. The bad thing is, of course, it's going to cost more bandwidth. So it's kind of a trade-off. Just keep that in mind. Let's go ahead and jump into the player network script. Go up to awake, and we're just going to set these values as soon as the program loads. So I'm just going to do it after the player name section, and I'm going to do photon network dot send rate equals 60 and photon network dot send rate on serialize equals 30. The default values are 20 and 10, so I'm essentially tripling the send rate of packets. Again, this might not be advised. I'm just showing you what a difference it can make. So save everything and go back to your editor. Now I'm going to go to File, Build and Run. Hit play in the executable as well, the editor. Make a room, join it on the executable, start it in the editor. Now if I go back to the executable and I move around and rotate, you can see that it's quite a bit smoother now. There is a little bit of a delay in the editor for how long it takes it to catch up to the executable location, but that's just something you have to kind of trade off with. You can either send more packets and get a more precise movement, or you can send less packets and have a little bit of delay. It just really depends what you want to do with that. All right, so close out of the executable and stop the editor. Next, we're going to talk about sending various data such as health, animations, and things of that sort. We're also going to talk about the proper ways to do it, or rather the recommended ways, so that users cannot easily hack your game.